Hello friends, we are MSc students of Sacred Heart College, Chalakudy. Today, we are going to conduct the analysis of cations present in solutions. Solution number 1. Ammonium. A little of the original solution is boiled with sodium hydroxide solution. And the evolving smell is noted. There is no smell of ammonia, so absence of ammonium. Next, we are going to do the intergroup separation. For that, first we take the test solution. Next, we add dilute hydrochloric acid to it. As you can see, there is no residue, so absence of group 1 cations, silver, mercury and lead. Then we dilute this solution. And it is heated. Then H2S is passed. As you can see, there is no residue, so absence of group 2 cation, bismuth, copper, cobalt, etc. Now H2S is boiled off. It is then boiled with a few drops of concentrated HNO3. Then ammonium chloride and excess ammonium hydroxide are added. As you can see, there is no residue, so absence of group 3 cation, chromium, aluminium and iron. Now it is concentrated. Then the concentrated solution is taken into a test tube. Now, excess of ammonium hydroxide is added. And H2S is passed. As you can see, there is a residue. There is a dirty white residue. So, presence of group 4 cation. The residue is then centrifuged. The centrifugate is taken for the analysis of group 5 and the dirty white precipitate is kept aside for the confirmatory analysis of group 4 cations. The centrifugate is then concentrated and thus H2S is boiled off. Now, the concentrated solution is taken into a test tube. To this, we add excess of ammonium hydroxide. And ammonium carbonate solutions. And the solution is warmed. As you can see, there is a white residue. So, presence of group 5 cation. Now, the solution is centrifuged. To the centrifugate, ammonium chloride, ammonium hydroxide, and disodium hydrogen phosphate solutions are added. The inner sides of the test tube containing this solution are scratched using a glass rod. As you can see, there is no residue, so absence of group 6 cations, magnesium, lithium, sodium, potassium, etc. Analysis of group 4 residue. The group 4 residue is shaken with very dilute hydrochloric acid. As you can see, there is no black residue, so we confirm the absence of nickel 2 plus and cobalt 2 plus. Next, H2S is boiled off from the solution. Then we add excess of sodium hydroxide solution. And it is boiled. As you can see, there is no brown residue, so we confirm the absence of manganese. The centrifugate is divided into two portions. To one portion, acetic acid is added and it is acidified. Then we treat the solution with potassium ferrocyanate solution. As you can see, there is a white precipitate. We confirm the presence of zinc. To the second portion, H2S is passed. As you can see, there is a white precipitate, presence of Zn2 plus confirmed. The precipitate is collected and is heated with concentrated nitric acid and a few drops of cobalt nitrate solution. A piece of filter paper is moistened with this solution and then it is burned to ashes. As you can see, there is a green tinted ash. The presence of Zn2 plus is further confirmed. Analysis of group 5 residue. The group 5 residue is washed with a little hot water. It is dissolved in minimum quantity of hot acetic acid. Now, the dissolved carbon dioxide is boiled off. To nearly boiling solution, a slight excess of potassium chromate solution is added dropwise with constant shaking. As you can see, there is no yellow residue, so absence of barium. The centrifugate is concentrated by evaporation. And this is divided into two portions. To one portion, we add calcium sulfate solution. And then it is boiled. At the same time, the inner side of the test tube below the liquid level are scratched using a glass rod and allowed to stand. As you can see, there is no scanty white precipitate, so absence of strontium. In the absence of strontium, next we test for calcium. For that, to the second portion of the centrifugate, excess of NH4OH is added. And it's followed by ammonium oxalate solution. As you can see, there is a white precipitate, so presence of calcium. The precipitate formed is calcium oxalate. To confirm the presence of calcium, flame test is conducted with the above precipitate. For that, the precipitate is mixed with a little of concentrated hydrochloric acid. It is made into a paste. It is shown to the non-luminous flame. As you can see, there is a brick red flame, so the presence of calcium is confirmed. The characteristic color is due to the de-excitation of the thermally excited electrons with emission of visible light. Thus, we confirm that the given test solution contains zinc as a fourth group cation and calcium as a fifth group cation.
Solution number 2. Test for ammonium. A little of the solution is boiled with sodium hydroxide solution. No smell of ammonia. Absence of ammonium. Intergroup separation. Dilute HCl is added to the solution. No residue. Absence of group 1 cations. It is then diluted. Now heated. H2S gas is passed through it. No residue, absence of group 2 cations. H2S is boiled off. Concentrated HNO3 is added. Now this solution is boiled. Ammonium chloride is added. Now excess of ammonium hydroxide is added. No residue, absence of group 3 cation. The solution is concentrated. Now excess of ammonium hydroxide is added. H2S gas is passed. No residue, absence of group 4 cations. H2S is boiled off. The solution is concentrated. The concentrated solution is added to a test tube. Excess of ammonium hydroxide is added to this solution. Ammonium carbonate solutions are added. This solution is warmed. White residue is formed. Presence of group 5 cations, barium, strontium, calcium. It is centrifuged. The residue is kept aside for analysis of group 5 cations. Analysis of group 6 cations. The centrifugate left after the removal of group 5 cations is concentrated. The concentrated solution is divided into two portions. Into one portion, excess of ammonium hydroxide solution is added. This is followed by the addition of excess of disodium hydrogen phosphate solution. Now, the inner sides of the test tube below the liquid level are scratched with a glass rod. A white crystalline precipitate is formed. Presence of magnesium. It is centrifuged. The precipitate is collected and dissolved in concentrated HNO3. This solution is boiled with few drops of cobalt nitrate solution. A piece of filter paper moistened with this solution is burned into ashes. A pink tint ash is produced. Presence of magnesium confirmed. To the second portion, a few drops of magnesium reagent is added, followed by excess of sodium hydroxide solution. A blue precipitate is formed. Presence of magnesium confirmed. Analysis of group 5 residue. Group 5 residue is washed with a little hot water and dissolved in minimum quantity of hot acetic acid. The dissolved carbon dioxide is boiled off. To the nearly boiling solution, a slight excess of potassium chromate solution is added dropwise with constant stirring. No yellow residue. Absence of barium. It is concentrated by evaporation. The concentrated solution is divided into two portions. To one portion, calcium sulfate solution is added and boiled. The inner sides of the test tube below the liquid level are scratched using a glass rod. A scanty white precipitate is formed. Presence of strontium confirmed. The precipitate is collected and made a paste with concentrated HCl on a watch glass. A little of this paste is taken at the end of a non-luminous flame. Crimson red color is produced. Presence of strontium confirmed. In the presence of strontium, to the second portion of the centrifugate, excess of dilute H2SO4 is added. A precipitate is formed which is removed. To the solution left, excess of ammonium hydroxide is added, followed by ammonium oxalate solution. No white precipitate is formed. Absence of calcium. Thus, the given solution contains strontium as group 5 cation and magnesium as group 6 cation. Solution number 3. Test for ammonium. A little of the test solution is boiled with sodium hydroxide solution. A gas with smell of ammonia is formed. A glass rod dipped in concentrated HCl is shown near the gas. Dense white fumes are produced. Presence of ammonium confirmed. A little of the test solution is boiled with sodium hydroxide solution. A piece of filter paper is moistened with Nessler's reagent. The filter paper is shown in the issuing gas. A brown stain appears on the paper. Presence of ammonium confirmed. Intergroup separation. Dilute HCl is added to the test solution. A white residue is formed. Presence of group 1 cation lead. This is centrifuged. The residue is collected and analyzed for group 1 cations. Analysis of group 1 residue. The group 1 residue is boiled with water. The residue dissolves. Presence of lead. This hot solution is divided into two portions. One portion of this hot solution is acidified with acetic acid and treated with potassium chromate solution. A yellow precipitate is formed. Presence of lead. The second portion of this hot solution is treated with potassium iodide solution. A yellow precipitate is formed. This precipitate dissolves on heating with water. The precipitate reappears on cooling. Now, the precipitate reappears as golden spangles. The presence of lead confirmed. Thus, the given solution contains 0th group cation ammonium and group 1 cation lead.